Hello, and welcome to the session on trustworthy storage, where we're going to talk about expectations and reality. My name is Eric Hibbard, and as you can see, I'm a practicing security and privacy professional. I've been involved in a wide range of international standardization activities, and relative to this talk, I was actually the ISO editor for the 27040 storage security standard, and I lead the U.S. national body activities to the ISO committee that deals with cybersecurity and privacy standardization. I also do quite a bit of work with the American Bar Association, which gives me a legal perspective on a variety of issues as well. So with that, I also should mention that within the Storage Network Industry Association, I chair the Security Technical Work Group and have been involved in security-oriented activities with SNIA since about 2004, so quite some time. So today's talk is probably a little different than in some of the other ones. My intention is to give you some background on some areas in security, and to a lesser degree privacy, that we're seeing emerge that I think ultimately will have an impact on storage systems and storage ecosystems, but it may not be immediately obvious that that's the case. And so we're gonna talk about some concepts, some frameworks, if you will, that will, I think, in many ways drive some of the future of security changes that will occur at the storage layer. The two that I'm going to focus on today are a concept of trustworthiness, and the other one is zero trust. And I'm going to try and bring those back to how they're different than where we are today with storage security and various other activities. All right, so obviously I'm going to start with trustworthiness. What is it? And sort of issues, and then move to zero trust, which is a different kind of beast, and then looking at this through the lens of securing storage. So first up, trustworthiness. Trustworthiness has, at least for me, has an interesting history, and one of the things that emerged a while ago in the United States is the Federal Trade Commission started paying attention to vendors who would make claims about the security or their product was secure. But if it turned out that, in fact, there were vulnerabilities, which is inevitable, and they knew about it, but they didn't disclose that information, when that came to light, there have been multiple instances where the FTC has basically filed deceptive practices against those companies. And the fines can be pretty steep. It could be measured in the hundreds of thousands of dollars. And equally important, you can be supervised for up to 20 years. In other words, you're having to report back to the FTC on a regular basis of how you're dealing with whatever the particular issue is. And in the case of unfair and deceptive practices, especially if it's aligned with security, that could be a problem. All right, so with that backdrop, as a practicing security professional, somebody who has operated in the arena of a storage vendor, clearly I wanted to be careful about using the claims about secure product. So the word trustworthiness was actually something that was very appealing, because at least from a dictionary definition, it doesn't necessarily mean security. Something could be trustworthy because a company is over 100 years old and it's been around, it's expected to be around in the future. It's dealt with its customer needs and things of that nature. But you notice I didn't say anything about, the product is secure. Well, that was the backdrop for a while. But what we're seeing now is that ISO has recognized that this trustworthiness term is actually is interesting and can convey a whole bunch of concepts simultaneously, assuming you can actually get it defined. And so they've undertaken an effort to basically define trustworthiness. And the definition, working definition, because this is a work in progress, currently is what you see. It's trustworthiness corresponds to the ability to meet stakeholders' expectations in a verifiable way. I don't want to say it's content-free, but it's pretty much content-free. What's worth noting is note 2 has a little more action. And in this instance, what they're highlighting is characteristics of trustworthiness include reliability, availability, resiliency, security, privacy, safety, accountability, transparency, integrity, authenticity, quality, usability, and accuracy. That's a tall order. And in fact, that's the focus of the discussions within ISO. And they're looking at this as almost a cross-cutting concept, if you will, in that it's showing up in artificial intelligence, it's showing up in IoT, and it's even showing up in some of the security and privacy standardization activities. So I'm going to touch on some set of these, which I think are core and to varying degrees play into needs within storage. So the first piece is safety, and although in this is one of those that from a storage perspective we don't necessarily talk a whole lot about. It does come into play when you look at things like racks and whatnot. But from here, the focus on physical injury and damage to the health of people, and whether that's directly or indirectly, and it includes environmental safety, living entity safety, and operational safety. Normally, it wouldn't be a big deal for us, but when you start looking at things like IoT, which are going to have interactions with storage systems, things that happen in the IoT space can and will have an impact on humans. And so it's important to keep this in mind because failures or issues here could replicate out to the safety side of the house. Security is obviously a no-brainer in this space, and especially for storage systems. From an ISO perspective, they're looking at it both from an information and a systems perspective, and they're specifically looking at integrity, availability, and confidentiality. CIA from a security perspective. So if you operate in the space, no big surprise there. But the fact that they are looking at the information versus system, is important. Privacy is the next piece. From a lot of the work that ISO is doing right now, the focus is actually on frameworks, laws, regulations. There are dependencies on from a privacy perspective on security and other facets. But in a trustworthy perspective, it's really looking at sort of the legal and the privacy framework piece, and security gets handled under the security moniker. The next piece that I'd like to bring to your attention is resilience. And the way it's described right now is kind of interesting. It's the system behaves in a manner to avoid, absorb, and manage dynamic adversarial conditions while completing the assigned missions and reconstitute the operational capability after casualties. In other words, this resilience means that the technology has the ability to adapt and bounce back as part of what it does, and that's an interesting concept. And of course, you can't do that in isolation. You're going to have to factor in the safety and the security and the privacy pieces in terms of how you go about doing this. The reliability, which in the storage world we're very, very familiar with. It's basically, it's a set of conditions under which the system is tested to demonstrate that the functions perform for a specific period of time. In other words, it does what it's supposed to do within, for example, 5 nines. And a lot of what the storage industry has had to worry about is, in that space. That's something that we know very well and have done great things in that arena. Okay, so sort of a visual view of these, and this is actually out of one of the ISO drafts. It's showing that what these attributes are and kind of the sub-elements that exist. So, security is a peer to safety, which is a peer to privacy, which is a peer to reliability and then resiliency. And there are these sub-elements that you potentially have to worry about. And this is what they're looking at. And I think from a high level, this is something that going forward as an industry, storage is really going to need to pay attention to this cross section. There are other components, but these are going to be, I think, the heart and soul in the future. I apologize for this diagram, but its intention is to show you the sort of the thought processes that are going on. So if you look at the very bottom, you see confidentiality, integrity, and availability, at the bottom, and the way the diagram is set up is it's showing that those are a factor of security. And then from security, you see there are these connections to safety and reliability and privacy and resilience. And if you were to look at the wording there, it supports. So to achieve the other elements, security is identified as a component of that. And likewise, you see that safety also supports security. And it's the combination of all of these and the interdependencies, the interplay, that in totality really make up trust. So trust is derived from all of these coexisting in a way that has an overall sort of positive effect on whatever it is that you're talking about the trustworthiness of. So this is significant because you're no longer looking at these as sort of individual components. You're no longer looking at reliability as just reliability. Now you have to look at reliability and at the same time, for example, privacy. So is there something that when you deal with the privacy piece, it has an impact on reliability? And the answer we already know. For example, with at-rest encryption, there have been instances where at-rest encryption can actually cause reliability and resiliency problems, just because of the very nature of that technology. But this is where ISO is currently thinking about this, and you should expect that in the future, the trustworthy conversation is going to be something that you're probably going to have to talk to, and it's all these elements, and you're going to have to essentially describe the interdependencies and the interactions of these components in your systems and your designs. Okay, so what are the processes to promote trustworthiness? And these are above and beyond those that you are probably already familiar with from a storage security perspective. So I'm going to go through these fairly quickly, but to give you an idea that in some cases they're building upon or they have dependencies on things that you're already doing, and but it may in some cases take it to another level. You may already be doing some of these, and that's great. But again, this is from a sort of a totality picture. It's like you don't get to pick, one or two of these. The expectation is that you're addressing most or all of these, and that again is a bit different than I think where we are today. So the first up is basically dealing with configuration management. And again, looking at configuration management from information assets and physical assets. So this is looking at, for example, configuration management on the system itself, and then what are the configuration management things that are there to deal with, for example, data. This next one is reproducibility of the build process. So when you have a product, can you get to a known secure state in that build process? And that's, if you think about that, that's important, because that means a product, before it goes out the door, you've already dealt with the security posture issues. In other words, you've installed all the software that has the security functionality, and it's configured correctly. It's configured secure by default. It's configured for privacy by default and by design. And you want to be able to do that in a way where it's reproducible. In other words, you can get to that known state. This becomes an important issue if you're doing anything around security certification, which we'll talk about in a minute. So the secure development process, I mean, are your engineering teams thinking about the concept of risk? Is this factored into the decisions they're making, both short-term and long-term? So the viability of the product may be somewhat dependent on the ability to maintain the security posture of that product. And if you made some poor choices in terms of selecting particular code or certain protocols, you're kind of asking for trouble. And but a lot of engineering teams are not thinking that far ahead. And from a trustworthiness standpoint, it's absolutely critical that the development process factors in the security elements. The next two, secure response, and incident response, these are things around how do you deal with the active changes in the threat landscape. Do you recognize when you've got a problem? And when you do recognize you've got a problem, do you have the mechanisms and processes in place that let you deal with it? And as opposed to having a customer come in and beat you about the head and shoulders, and then you respond to it. Are you doing things proactive? Are you monitoring, for example, the National Vulnerability Database and recognizing almost instantly when something comes in that, oh, that applies to me. Oh, I'm going to go take care of this. Those are the kinds of things. And of course, embedded in this is how do you deal with the disclosure piece? And that's a fairly important aspect of this as well. Systems management and security management processes. This is something that storage management has long been a concern of the storage industry. But now what we're talking about is how do you manage the hardening of the systems, and how do you deal with managing the security aspects of this stuff? And those all have to be factored in and clean. Let me give you an example. Transport layer security, or TLS, is typically a pretty important component of storage management. Okay, most storage products actually have some sort of TLS support. The bigger question is, does that support include the ability to configure the TLS to the point of where you can exclude certain protocols, user protocols, certain cipher suites, certain crypto, and the customer can do that? That is not so common, and that's an aspect of this. Next up is supply chain processes. So making sure that authenticity and integrity issues are basically dealt with. In particular, there's a lot of concern about counterfeit components being placed into systems, and what does that actually entail. Obviously, the next to last one is dealing with international industry standards. So if you're going to talk about trustworthiness and security, what's the basis for that? Did you just make it up? How does it, if you talk to lawyers, they'll talk about reasonable security, but what constitutes reasonable security? So do you have a leg to stand on when you say, oh, we've developed against best practices? Well, in the security world, that actually means, you're using a particular security framework as the basis. You can't just, make it up. They're going customers in particular may actually demand adherence to particular security frameworks. So you may have to be able to, you used one, they're expecting something else. You may have to be able to do the crosswalk between those. The last element sort of gave you a teaser to is evaluation Third parties, basically accreditation. This is where crypto, for example, against FIPS 140 certification, could be common criteria. In fact, just this week we had an ISO SC27 meeting, which deals with information security, cybersecurity, and privacy standardization. And there's some discussions underway as to whether you can do common criteria with regard to cloud. So there's lots of interesting things happening in this arena. Okay, so what kind of protections are needed for trustworthiness? Then I'll go through these fairly quickly, but basically it's protection from. So, security, we always look at the underbelly, what we're trying to guard against. So unauthorized disclosure. So this really plays into the privacy space, but it also, if you have credentials that are being exposed, this, can seriously undermine the security of a system, at least the posture. Protection against modification. This is a fairly important concept. If you look at a lot of the privacy laws that have been implemented, in particular the EU's General Data Protection Regulation, or GDPR, they've defined data breach in a way that corruption or destruction of data constitutes a data breach and essentially invokes all of the trials and tribulations around what GDPR is getting at. And so that simple sort of redefining has a pretty major impact, because in the past, storage engineers going out and doing updates on firmware and whatnot might not have ever been a party to a data breach. Now, if your personnel go out and do an update and that firmware has an issue, or the process that's used has an issue and results in data corruption, you could have just bought the farm in terms of having caused a data breach, and for your customer, and clearly your customer is going to want to share. So the modification and then this temporary or permanent loss both sort of play into that arena. So again, that's about the availability piece as well. So loss of confidence in an information asset. This is kind of back to this whole trustworthy thing. If you've got a vulnerability that you basically tell the customer, we're not going to do anything about this. Somebody who's run data centers in the past, I can pretty much guarantee if you told me that as a data center manager, I'll be looking at your competition. So how you respond to this threat landscape and you respond to the concerns of your customer base is going to be a huge, huge issue. And it requires some upfront thinking in terms of how you're going to deal with it. This last point is the protection from interference. So this is where you're worrying about how do you sufficiently isolate. And isolation could be, if you think about multi-tenancy or secure multi-tenancy, how the tenants aren't basically causing each other difficulty. But it could be how your cloud versus your in-house, your on-site activities are interacting or not interacting, how they're isolated. So this concept of isolation can be fairly important. The example I like to use is the secure multi-tenancy. What exactly is that, and how do you deal with that? And we'll talk a little more about that later. Okay, so there's some controlling aspects of capabilities and trustworthiness that you've got to worry about. All right, so one of those is how the control over error reporting and diagnostics. And this is fairly important because this dealing with these may actually give you clues that you're under attack. So part of this is health and fault monitoring, but in some cases, the attacks will sort of first sign of a problem might be that you're getting some sort of error reporting. Case in point, you may be under attack with ransomware, and certain system files may have been encrypted, which means the system starts generating errors and warnings. And if you're monitoring that, then you have a heads up that you've got a problem. Well, why is that important? Well, a lot of this malware is actually geared to basically take out your entire ecosystem, not just one system. So if you respond fairly quickly to that one system, you may be able to save major chunks of your infrastructure. So again, this is back to looking at sort of an ecosystem perspective as opposed to sort of individuals. The next is control over real-time protection capabilities. And I'm going to talk more about this with Zero Trust, because this is literally, it's not a one and done kind of thing. This is, you're having to adapt to what we call zero-day events. You may not have a whole lot of information. You may be changing what individual users or systems are allowed to do or interact with, and being able to deal with those real time is absolutely an issue today and becoming even more important. The third one, dealing with key escrow capabilities. This plays into the encryption arena, but do keep in mind that if you lose your data encryption keys, you've basically lost the data. And so what steps have you taken to basically deal with that? And this is particularly important when you look at disaster recovery, business continuity scenarios. Depending on where your encryption is actually taking place, you might have successfully replicated all the data to another data center, and you're ready to go, except that what you replicated was ciphertext. In other words, everything's encrypted, and you forgot to basically make sure that the encryption mechanism, but more importantly, the keys are over there that you can use those. So again, this is a sort of the holistic view on things. And then last but not least is having the ability to essentially make changes to especially some of the security features. Again, responding to that threat landscape. So do you have the ability to rip out TLS 1.2 and replace it with TLS 1.3 without gutting the product or basically obsoleting the current product? And so how you approach this, especially from sort of a modular perspective, whether you're adding functionality or getting rid of functionality, is actually a big concern in trustworthiness space. All right, so I'm going to shift gears a bit here and talk about Zero Trust. So what is it? So it's basically a collection of concepts and ideas. You're minimizing what they call uncertainty here, but essentially you're trying to enforce accurate, least privilege per request access decisions. Think about what I just said. That means every time you do something, you're doing it in a way where you have the bare minimum privilege, just enough privilege to let you do that. And it's being enforced, and it's always accurate. So if there's a real-time change, that's reflected instantaneously. And this is all done in an environment where the network is basically assumed to be compromised, fully untrusted. That's a pretty tall order, and that's basically what Zero Trust is trying to do. If you haven't seen the new NIST special publication 800-207, this is the NIST Zero Trust architecture, basically, and it's an interesting read. It's also free, so if you're looking for a source to look at, I would definitely recommend taking a peek at it. Right, and so what are some of the tenets of Zero Trust? And again, remember this. What I'm going to describe here, it's not just one of these that you do. You're looking at all of these simultaneously, and that's where the difficulty comes into play. Okay, so everything is treated, so all data sources and computing services, they're considered resources. So everything is looked at from a resource perspective. So in every interaction with these resources, is essentially a lot of what the rest of the Zero Trust is about. All communications is secured. It doesn't matter where it is. It can be inside of a storage system, for example. And the expectation is if you have a communication between like a disk controller and a drive, that you're securing that communication. There's no trust anywhere, right? Or said another way, trust but verify, which is sort of a security mantra. What you're seeing is zero trust. It really is zero trust. Assume everything is hostile. Everything from an enterprise resource perspective, access is granted on a per session basis. So every time you reach out to get something, a whole set of verifications and authentication are performed before you're given access to it, and that can take on lots of different sort of. So you may be always allowed to get at something, but the time of day or your location may dictate whether you get at it or to the degree that you can actually use the resource. Right. So continuing with these tenets, there's a policy that sits behind all of this, and that policy is intended to be very dynamic. So if somebody's terminated, for example, from within the company, then that's reflected in the infrastructure, and it immediately is factored into policy decisions. And as I said, it's who you are. It can be based on the application you run. It could actually be different based on whether you use your mobile device or your laptop. Could determine what you have access to. Could be where where in the world that you're sitting at any given time. And there may be some other behavioral things that are going on. So if you haven't used multi-factor or two-factor authentication, just by virtue of doing that, there may be restrictions on what you're permitted to do. All of this is basically codified in policy, and then based on what happens, we'll determine what and how you can access things. And of course, there's monitoring measures, for the integrity and security posture of the assets. So think about this: when your laptop, you initially go to connect. Part of the process may be to do a quick scan of your system to determine whether it's become vulnerable since the last time it connected. And in fact, if it has been infected with some malware, connection may be refused or it may be diminished. So again, this is a back to that, trust but verify. So is the client affected in a way that if it connects, that it could basically infect the infrastructure? If the answer is yes, you don't get to connect. So all resources are authenticated in authorization, and it's all done dynamically, and it's strictly enforced. So again, least privilege, root and admin, forget about it. Doesn't exist with these kinds of accesses. You literally only get access to what you really, truly need to have access to. As part of this process, you've got to have a lot of information on the assets and the resources, and how they're interconnected and the security posture, because all of this factors into how you execute the policies and whatnot that are being used. So you've heard me talk a little bit about networking. So, but this is sort of at the heart and soul of zero trust. It's basically, there is no trust, and there is no implicit trust zone. So there's not an inside network and an outside network. It's all outside network. And even within a system, it may be an outside network, and that's kind of core to the zero trust mentality. As you're probably guessing, this is not trivial to implement, and this is a fundamental change in how organizations structure their infrastructure and their networks if they go down this path, right? Part of the reason for going down this path is increasingly we're seeing that devices that are on a network, even if it's like your local area network, they may not be owned or even configurable by the enterprise. They may be there by a third party, and there may be problems with those devices. And so there, that's, and we're seeing increasingly a lot of data breaches that occurred is because you've got, your supply chain isn't doing what they need to be doing. Well, zero trust basically, factors that in, that they probably didn't do what they should be doing. So no resource is inherently trusted. So anytime a resource needs to interact with another resource, your laptop with, an email server, for example, there's no assumed trust there. It's all basically got to be established using security mechanisms. And again, back to this ownership issue, not all resources are on enterprise-owned infrastructure. Cloud is the easy example here. So especially you could be running in a hybrid cloud kind of scenario. Zero trust absolutely factors that in. It's assuming that you may be using assets that you have no ownership for, and it factors that into the equation, so to speak. So remote enterprise subjects and assets can't fully trust their local network connection. I've said this multiple times. So it's a different perspective, because if many security professionals will tell you, for example, don't connect to the hotel Wi-Fi. Well, in a zero trust scenario, everything's assumed to be as bad as the hotel Wi-Fi. So it doesn't matter where you're at, in a nutshell. So it really does fundamentally change the game, but it does mean you've got to make a lot of changes to your systems and infrastructure. And the assets and workflows moving between enterprise and non-enterprise infrastructure, there's really a need for consistent security policy and postures. So that the security posture is something that is basically tested on a regular basis. So if you've got a third party that's in your infrastructure or participating in that, there's going to be a desire to basically understand what their policies are and the postures. And if they don't align well, then again, that's going to affect what you can do. Okay, so lots of sort of interesting concepts. So how does this materialize? This is a nice little diagram, but you see kind of at the heart of it, and that's just to the right of the little black box that says system, you've got a policy enforcement point. So this policy enforcement is core to how zero trust works. It's making decisions based on a whole bunch of different things. And the policy engine, if you will, is making real-time changes, which is basically updating the enforcement point, and then it's taking information based on your system, you as a user, your a variety of other issues before it essentially lets you in. To do all this, though, it requires that you've got a wide range of technologies that are basically being used. So you've got data access policies and endpoint protections. You probably have some sort of public key infrastructure, ID management, and SIEM systems that are all sort of plugged in here. And on the other side, why are you doing this? Well, you're trying to deal with accountability and traceability, the threat landscape. So any sort of threat intelligence you've got, compliance and what. The key thing to think about is this policy engine. It's getting real-time inputs from a bunch of external sources, and it's dealing with those real time. And that's a pretty big change from how we see a lot of the infrastructure going. So there are a bunch of different deployment models that you can use for zero trust. These are 3 examples that I thought would be kind of interesting. So the top left, think of this as you've got a laptop that's got basically an agent that's going to ultimately talk to a gateway that's going to then wrap, if you will, some sort of data resource. Okay. However, the importance of this is that your laptop is not going to be able to actually have any kind of dialogue with that resource until it's been duly authorized. In fact, you might not even know how to reach it. And even if you could, if you knew the IP address of that resource, it's not going to respond to you at all. So you can't do a denial of service attack against it, because it will absolutely drop the packets at the lowest sort of network level until it basically is told, yeah, you can talk to him. And so there's a process that's typically involved in terms of how even that initial connection gets set up. So this is where you can actually do computing in very unsafe environments, and the bad guys, if they're scanning your network, they're not even going to see these resources. They just disappear. In fact, I've had some security guys grumble because when they go to try and do security scans against the infrastructure that's being protected this way, they can't see it, so they can't even determine whether it's got vulnerabilities or not. And they ask to have the shields drop so they can do the verification, which always gives me kind of a chuckle. The next model, which is kind of similar, on the upper right hand side, think of this same kind of dance where you've got maybe a laptop with an agent running there that's interacting with the policy engines and whatnot. But then it's talking with a gateway that, if it gets to the gateway, is then going to give you access to a whole bunch of services. This could be like in your DMZ, so you could be your mail and calendaring and a bunch of different services. So you can bundle up a bunch of stuff that sits behind one of these gateways. So you could do it, on a service by service basis, or you could actually do it so it's like a bunch of stuff that's in a cul-de-sac. Some options in terms of putting gateway, the agents on whatever the endpoint device is. It might not be an option, and so then there are other models that basically allow you to have essentially a vanilla system that then is talking with a gateway portal. And this little dance in terms of policies and identification and authentication, everything else is done against the portal. And if you get through that, then you get out to the resource. Again, the resource itself isn't visible, and the portal itself might not respond to any sort of interactions unless it's, from a policy perspective, knows that it's allowed to talk to your device. And if your device has problems, then the portal might actually reach out and say, "Oh, here's a little agent. You need to go run this to check and see if you've got any malware running." Okay, so let's talk a little bit about implications and challenges that these two, trustworthiness and zero trust, might introduce for storage. All right, so sort of a recap on some things that I've already mentioned. Privacy regulations have really redefined data breaches, and it's affecting storage systems and vendors in this space. It's showing up in contracts. It's showing up in how the systems are being connected, and so it's important that you're aware of this, because this is a driver in terms of why organizations are going to adopt some of these approaches. The attacks, and in particular ransomware, is a scourge that has lots and lots of enterprises very, very concerned. They're being explicitly targeted. The bottom line is the bad guys have figured out that it's actually easier to basically deny your access to data than to actually move it off and try and monetize it by stealing credit cards and things like that. It's just easier to hold at ransom. And storage is, well, it's the bucket holding the bits, and if it gets hit, or if the systems that are using the storage get hit, the storage systems are caught up in this one way or another. As I said, there is this deperimeterization of enterprise networks. It's pretty much understood that firewalls are a little more than a speed bump, especially when you factor in that you've got Wi-Fi and you've got mobile devices and bring your own devices that are being used. There are many, many entries into the enterprise networks, and so there's anybody that's assuming that they've got a hard, impenetrable, crunchy shell on the outside, and that's going to do it for them, they won't last long in a security position, if that's sort of the perspective. The last item is dealing with, all right, so you put data on storage media, and it turns out it can be fairly difficult to get rid of it. And it's becoming an issue because there's a desire to essentially reuse technology. We've seen, for example, in Europe, that there's a regulation that is requiring some specific technology when you have storage systems of a certain kind to encourage reuse. And We don't expect that that's going to be a unique situation. We think that reuse, green storage, green servers, green something is going to be important, and it's not just about power consumption. So media absolutely plays into that, and of course that's where storage lives. When I talk about storage security, or at least contemporary storage security, there are some specific things that come to mind. None of these should be shockers. Most of this is defined in the ISO storage security standard. So it's basically system and network hardening, basic security, dealing with the storage management, making sure that it's secured, that because it's privileged users, that those privileged users have sufficient restrictions on what they do, because they could be very damaging. Accountability and traceability is part of that. Dealing with data access, how do you do this in a secure way? At a bare minimum, that you've got some level of authentication going on, maybe more if you can swing it. Encryption and key management, especially data at rest encryption, is pretty much assumed to be a requirement for multiple sectors. Likewise, media sanitization. We were just talking a little bit about this. How do you make data go away, especially sensitive data? And then the last piece here is leveraging the security infrastructure. This is the customer infrastructure. So you've got to have the ability to plug in using some of these protocols that some of them are fairly ancient, others are fairly new, but doing it in a way where you're not forcing the customer to change their infrastructure to accommodate you. You have to basically fit into whatever it is they've done. So if you move up a little bit, what do I mean by advanced storage security? So these are things that maybe less common, or where the contemporary are pretty much ubiquitous. These you may have sort of bits and pieces. So storage link encryption. So if you're familiar with Fibre Channel Security Protocol, you maybe have implemented the encryption over the connection between the host bus adapter and the actual storage array, for example. Secure autonomous data movement. The concept behind this really came out of information lifecycle management. But think of this as you may be autonomously moving data around to deal with something, a piece of data is just not used very much, and you're trying to maximize your expensive storage, and so you're moving behind the scenes data between different tiers of storage. Right? So tiered storage may be a concept you're familiar with. Well, every time you move this data, you leave a data dropping, and over time it may go away depending on the system. This concept means you proactively manage that. You park a piece of data somewhere and you no longer need it, you make sure you get rid of it. Another facet of it is, have you moved data into technology that may or may not be appropriate for the sensitivity of the data? If you have a storage system sitting in a broom closet, you clearly don't want the recipe for Coca-Cola showing up there where somebody could basically easily steal it. You're going to want that to stay in the most secure data center with maximum protections. So how you deal with that is what's bundled in here. Secure multi-tenancy as opposed to multi-tenancy. This is dealing with the individual tenants aren't impacting each other. In fact, they don't even know that they exist. Sort of the comparison is that you could have 7 tenants in a secure multi-tenancy environment. From their perspective, it should be identical to running on dedicated hardware or systems for each one of them. That's sort of the ultimate test, how close you get to that. One of the attributes of this that's a little different from multi-tenancy is if you've got 7 tenants, they could be competitors, and you would actually have to plug into 7 different security infrastructures to deal with the 7 tenants. And so that's a little different view than multi-tenancy, which might actually have a common security infrastructure. So it's just a couple of examples. Long-term retention and preservation. Think immutability, and what does that mean? And again, how do you protect it? And then when you no longer protect it, how do you make it go away? These are all kinds of issues. Long-term is longer than 10 years. So what kind of media are you using? How are you ensuring that you don't have bit rot that gets replicated over time? How do you detect that? How do you deal with, encryption where you've got to change algorithms, in 20 years? How do you deal with a situation where none of the data owners are currently alive, but you may need to get access at some point? Things of that nature. Next one is software-defined whatever. Software-defined storage, software-defined protection, software-defined networking. What are the security implications and issues around us? We're beginning to see activities in this space. Software-defined protection, Cloud Security Alliance has been doing work in that space for quite a while. It actually turns out to be a subset of Zero Trust, which is interesting. And cloud storage, and dealing with sort of hybrid scenarios with cloud storage, or what about multi-cloud kinds of scenarios? Again, these are new areas that are being discussed by cloud service providers and customers to a certain degree. The security implications on these change. I think federation. Okay, so coming back to trustworthiness, what are the kinds of things that you need to worry about? Well, you have ecosystem hardening. This is not just system hardening. You have identity and access management and federation. So this is not just simple authentication and authorization. This is much broader context. Dynamic access control with constraints. Think of maker checker. So you've got two people that have the same access, but it takes two of them in operating in different capacities. It's kind of like launching a missile where it requires two guys, each with their own key, turning the key at exactly the right time, and neither one of them can turn both keys at the same time. Tamper-proof. So mechanisms that guard against systems being changed. So this is hardware roots of trust that help you guard against malware. But it may be immutability and things of that nature that come into play. Isolation and sandboxing. Doing this in such a way that it may actually involve security kernels. So for example, all I/O is actually controlled with true security mechanisms. Real time. It comes up over and over again. It's not well, when I booted up 6 weeks ago, this was what I worried about. It's how do you protect yourself real time against malware, whether that's changing signatures from your antivirus software to recognizing 0-day events because you see some anomalous behavior and what your known good behavior is. You absolutely want to exploit all the protections that you have at your disposal, and that they are sort of optimally configured at all times. And then monitoring plays into this on a regular basis. And monitoring is not just logging. Monitoring is you're taking logs and they're actionable. All right. So you're looking at regular operations. This is how you know, am I doing something that I normally do, or is this anomalous? And then the other piece is from a forensic perspective. So we actually had an incident. Do I have enough information that I can go back and figure out what happened and who did it and things of that nature? So some final thoughts on all of this. Clearly adversaries are changing their attacks at a rapid pace. This has definitely been the case. The pace is quickening. And as a defender, you have to be nimble. Storage from a security perspective has not been nimble, and that's a change that you should absolutely expect and hopefully you embrace. Data is today's currency, and storage kind of lives in that space. So you're on the line of fire. It's just a fact of life. And I think the ransomware view is really, been a wake-up call for a lot of organizations because, well, it's actually more valuable to the bad guys to deprive you of access than to use it themselves. And that trend is not going to go away. And last but not least, We've got lots of emerging technologies, 5G, IoT, artificial intelligence, blockchain, the list goes on and on. Many of these are going to basically add new requirements and dependencies for storage. And in particular, I look at 5G and IoT, that combination just seems to be a forcing function on how we think about storage. Is it going to be all in the data center, or is it going to be out on the edge? Well, time will tell, but early indications are it's probably both. And so the security implications on that become pretty important, especially when you think about what I was talking about, zero trust. So I'd like to thank you for your time today, and I hope that you found some of this useful. The intention was to give you some insights into some somewhat edgy parts of what we're seeing in the security world. A lot of this is not easy to implement, and it's going to require some forethought and some time to basically deal with it. If you liked the session, or if you didn't, we absolutely would love to have your feedback. So please take time to rate the session. With that, thank you again, and I hope this was of value to you.